Hello everyone, welcome back to our MySQL Learning Series. I am Ajit. In last video, we covered data types and operators. Today we are going to explore very important concept that is keys and relationships in MySQL. Whether you are a school student learning database for the first time, or a college student preparing for exams, or a working professional who wants to understand the real world database designs, this video will help you to grasp how data connects inside MySQL tables. What are keys? Think of a key like a special marker or identification tag in a database. Keys help us to uniquely identify records, link tables together, and keep our database or the data accurate without duplication. The real world example is every person has an unique Aadhaar number. A student can have a student ID or an employee can have employee ID. It uniquely identifies the, the person who you are. Similarly, in a database, keys uniquely identifies each record uniquely. Okay. So what are keys in MySQL? So we will go through most common types with each example. There is a primary key, foreign key, unique key, composite key, candidate key, and alternate keys. Okay, these are most common types of keys present. So, primary key. So, primary key uniquely identifies each record in a table. It cannot be null. Primary key cannot be null, must be unique. Okay, so every value must be unique. Whenever we create a column, okay, with primary key, assigning it as a primary key, so that column cannot contain a duplicate value or a single value twice, and it also cannot contain the null value. There should be some specific value. Okay, so let's take an example. Okay, so we will create one table, create table students. Okay, we will create the students table. Then first column will be student ID. It will be of int type, int data type that we saw the different types of data types present in the last lecture, and we will assign this will be our primary key. Okay, so then student name will be the second column. It will be of varchar data type, and then the class, like in which class student is learning, that class it will also be of varchar data type. So in this way we can create the student table. Here student underscore id is unique for every student. Okay, no duplicates allowed it, and it should not contain the null value. So that means student underscore id is nothing but our primary key. So we'll go to the next, foreign key. So a foreign key connects one table to another. Okay, foreign key help us to connect two tables. It links columns between tables to build relationships. Okay, to build the relationships between two tables, we use the foreign key. So let's take an example. We will create. We will see the example in MySQL Workbench. So we will create the table classes. Create table classes. So first column will be class ID. It will be of int data type, and it will be our primary key. The next column will be class name. It will be of worker data type. Then the next column will be the class name. Okay. So this will be our classes table. I will run this. Then we will create another table. Create table students. Okay. Already we have students table. So I will just take the students underscore one. You can give any name, but so to avoid the same name, I am giving student underscore one. Okay, and here the first column will be student ID. It will be of int type and the primary key. Then next column is student name. It will be worker data type. Then class underscore ID. Class ID will be of int type, and it will be of then we will create the foreign key on the class ID, which is going to refer it will ref it references to the class ID from classes table. So in this way we can create the foreign key. So here the class ID is nothing but the foreign key, which will help us to connect the classes table with students underscore one table. So in this way we can create the primary key and the foreign key. So then we'll see the unique key. A unique key ensures all values in a column are unique. Okay, so duplication is not allowed. But at the same time, Unique key allows single null value. Okay. In a column, one in a column, one row can contain the null value. So that is the difference between unique key and primary key. So we will create one more table. Create table employees. The first column will be employee ID. It will be of in data type and primary key as well. So then the email, which will be of worker data type and the email for each employee should be unique. So I will run this. Okay, employees table is already existed. That's why I will rename it to employees 1. Now we will run it and we can see the query has been executed successfully. And here we have created the unique key employee column. Okay. So we'll see the next key, that is composite key. A composite key uses two or more columns together to create a unique combination when one column alone isn't unique. Okay. So what is composite key is nothing but the when we are unable to uniquely identify each record present in a table using single column, then to create the uniqueness, we will combine two or more columns. Okay. So that key is nothing but the unique key. So you can see in the example, we have created a create table exam underscore results. Then student underscore ID is a column name with int data type. Then we have student underscore ID that it is also of int data type. Then we have marks, same int data type. And then we are creating the primary key based on students underscore ID and subject underscore ID, because a student can appear in many subjects. Okay. But the combination of student and subject must be unique, and it will be unique certainly, because there will be only one entry for a one student and one subject. So combining the student and subject will give us the uniqueness. So this is nothing but composite key. Then we have candidate key. So a candidate key is any column that can be chosen as a primary key. Okay. Candidate key is any column that can be chosen as a primary key. Out of all these candidate keys, one is selected as a primary key. Okay. You got the point? Out of all the candidate keys, one is selected as a primary key. So in the students table that we saw, both student underscore ID and email could be candidate keys. Okay, because both can uniquely identify a student. Alright. Forget about student. Let's see this table. Employees underscore one table. Here, employee ID and the email both could be candidate keys because both can uniquely identify the employee. Okay. So next key, alternate key. So once we chose a primary key, the remaining candidate keys becomes alternate keys. Okay. So if employee underscore ID is a primary key or the student underscore ID is a primary key, then email is alternate key. Okay. So in this example, if we choose employee underscore ID as a primary key, then the email will automatically be the alternate key here. Or in case we choose the email ID as a primary key, then employee ID will be the alternate key. Okay, but here we can see employee ID is primary key, that's why email is alternate key. So these are the keys, common keys present in MySQL. Okay, so relationships in MySQL. So now that that we know the keys to connect the tables. Okay, now we will see the relationships between tables. Okay, relationships define how data in one table relates to another. Okay, there are three main types in relationships: one to one, one to many, and many to one. One to many and many to one both are same, so we will only see one to many. Okay, so one to one relationship. Each record in one table relates to exactly one record in another table. Okay, so let's take the example of student underscore detail. Okay, so we will create using MySQL Workbench. We will see this example. Okay, for one to one relationship. So create table student. We will name this table as student underscore details. Okay, the first column will be student underscore ID. It will be of int type and primary key. Then next column will be address. It will be of varchar data type. Then we will create the foreign key on student underscore ID, which is going to refer the student underscore ID from students table. Okay, students. It is going to refer the student underscore ID from students table. I will run this and the query has been executed successfully. So each student has one detailed record. Okay, one student, one address record. So that's why it is one-to-one relationship between student details table and student table, because each student is going to have only one address. Uh, when it comes to real life example, We know that one person has only one Aadhaar number. So this is also the example of one-to-one relationship. Then one-to-many relationship. A single record in one table can relate to multiple records in another table. Okay, as we all know, like one record in one table can relate to multiple records in another table. So we have two examples here. So two tables here. Create table, teachers. We have teacher ID as int primary key and then name of the teacher as overcarrier data type. Okay. Then we have the table, create table subjects. Okay. Subject ID int primary key, then subject name, then teacher ID int type. Then we have foreign key. Okay. That is teacher ID is foreign key which is going to refer or it references the teacher ID from teachers table. So this subjects table and the teachers table will get connected with this foreign key. Okay. So one teacher can teach multiple subjects. Okay. But one subject can be taught by one teacher. So this is nothing but one-to-many relationships. Okay. One teacher can teach multiple subjects, but each subject can be taught by one teacher. So real life example, one customer can place many orders. Okay. When it comes to e-commerce website, e-commerce store, one customer can place many orders. This is nothing but the example of one-to-many relationships. Then we have many-to-many relationships. Okay. So a record in one table can relate to multiple records in another table and the vice versa. Okay. So this is usually implemented using a junction table or the bridge table. So we have students table, then courses table, and then we have student courses table. Okay. A student can enroll in multiple courses, and a course can have many students. Okay. One student can enroll in multiple subjects or multiple courses, and each course can have multiple students. So it is the example of many-to-many relationships. So we are using junction table or the bridge table called student underscore courses to establish the many-to-many relationship. We cannot directly establish many-to-many relationships between two tables. Okay, for that we use bridge table or junction table. Uh, let's take an example of actor. Okay, one actor can work in many movies, as we all know, correct? And each movie can have multiple actors. So both way we have many-to-many relationships. So in this way, we have seen the different types of keys present in SQL and the type of relationships present. Okay. So primary key and foreign key are the most common ones. Okay. That we use. And relationships show how tables connect one to one, one to many, many to one, and the many to many. But one to many and many to one both are same. So that's why one to many is we prefer. So once we understand how to design tables using or with the help of keys and relationships, we can model any real world system, whether it is a school data, hospital management, or the e-commerce website. So hope you like this video. Do like, share and subscribe to the channel. Thank you.